Hello everyone, my name is Alejandro Duran. I'm a student, I'm studying petroleum engineer, and welcome to this video. Today I'm gonna talk to you about the technologies and key process in offshore well drilling, particularly in deep waters. So let's start. This field has revolutionized the energy industry by allowing access to natural resources located thousands of meters below sea level. So today we're going to break down everything you need to know about the platform use, advanced tools, control system, and the complex drilling techniques involved. So deep water drilling not only requires robust and specialized equipment, but also meticulous planning and total control over environment conditions. So this is one of the most challenged and exciting fields in energy sector. So let's begin with the types of drilling platforms. Well, the types of drilling platforms. When we talk about offshore drilling platforms, the platforms play a fundamental role as they support the entire operation and allow drilling activities to be carried out safely and efficiently. There are several types of drilling platforms, and the selection of the platforms depends mainly on the water deep and environment condition. So let's explore the most commonly used types. First one, we have the fixed drilling units. These kind of platforms are used in shallow waters, usually and depths of up to 100 meters, and they are permanently fixed to the seabed using structures that allows multiple wells to be drilling from a single location. Their advantage are high stability since they are anchored to be seabed. Another advantage is the ability to drill multiple wells from the same position, and the disadvantage are limited to relative shallow depths. And second one, we have the mobile drilling units. In this type of drill units, we find several types of platforms that are much for versatile since they are not fixed on to the seabed. Their things allows them to move and adapt to different water depths. So let's look at some of the most important types. First one, we have the submersible platforms. Submersible units evolved from a barge and are mainly used in very shallow waters, such as rivers, bays, or swamps, with depths ranging from a low depths. This type of platform has two hulls, one that floats on the surface during transport and another that submerges during drilling operations. Their advantage are a low operation cost in very shallow waters, and a disadvantage are that can only be used in extremely shallow waters. This one limiting their range, the range of operation. We have the jackups units. These units also known as jackups. These jackups are used in depths up to 19 meters. These kind of units operate by raising the platform of the water using long leads that extends to the seabed, allowing them to remain stable in adverse conditions. The advantage of these jackups are ideal for shallow to medium depths, with greater stability than floating platforms. This one can be easily moved between locations. And the disadvantage of these units is that not suitable for deeps greater than 19 meters to leg limitation. We have another kind, the semi-submersible platforms. They are one of the pillars of deep water drilling. These platforms float on the water, but are partly submerged to gain stability. They use anchors to stay in place and can operate in depths of up to 2,000 meters or more. The advantage of these kind of units are the high stability, even in a raw sea condition, versatility, suitable for both drilling and production in deep waters. Their disadvantages are that these kind of units have a higher operation cost due to the advanced technology and the need for anchors or dynamic position system. And we have another kind, the drill ships. The drill ships are perhaps the most versatile and mobile units. They are equipped with all the necessary equipment to drilling in depths of over 3,000 meters. These ships use anchoring system or dynamic position to maintain their exact location during drilling. Their advantage are the total mobility, as they can quickly move between drilling sites. Their units are ideal for ultra deep water projects, and their disadvantage are more vulnerable to raw sea condition and require complex dynamic positions to stay stable. Another kind of units, we have detention leg platforms. Detention leg platforms are advanced structure using ultra deep waters, typical at depths greater than 6,000 meters. They are kept in position by legs attached to the seabed with tension cables, allowing them to move with the waves without drilling laterally. Their advantages are extremely stable at great depths. These units are designed for a long-term operation. Are ideal for oil and gas fields in constant productions. Their disadvantages are the expensive construction and maintenance due to the complex of their design. And well, in this kind of units, we have the dynamic position platforms. These platforms are not anchored to the seabed. They use a computer-controlled cruiser to maintain a fixed position, making them ideal for ultra-deep waters. This system relies on satellite signal and seabed transmit that in real time information to adjust the platform position. Their advantages are great flexibility and mobility, as they don't depend on anchors or cables. And the units are ideal for deep and ultra deep waters, especially in areas with strong current or winds. The disadvantages are huge fuel consumption that operation cost due to the position technology and through thirst. Well, each type of platform has a specific use depending on environmental condition, the type of well to be drilling, and the water deep. Fixed platforms are excellent for shallow waters, while semi-submersible platforms and drill ship are essential for extreme depths. Mobile units such as jackups offer great flexibility to adapt to different conditions. With this general overview of the types of drilling platforms, it's clear that each plays a crucial role in offshore operation. So next we will look at some of advantage tools that making drilling in this condition possible. Well, we continue with non-conventional drilling tools and equipment. Once we have the right platform, the selection of the right platform, the next step in the operation is to use the correct tools for drilling in deep waters. In these conditions, in this kind of operations, the conditions are extreme, and special tools known as non-conventional are used due to their advanced features and their ability to operate in complex environments. Deep water drilling would not be possible without special equipment. Some of tools used are very different from those found in onshore drilling. So these tools are very important for the operations. Well, among them is the motion compensator system. This equipment is essential for counterizing wave movements and keeping the drilling stable. So there are also the marine rise system, which connects the drilling equipment to the subsea wheel and transport fluids to and from the seabed. So additional of these kind of tools, there is a riser tensioner system. This system ensures that the pipe remains under the proper tension during operation. Maintaining the correct riser tension is crucial. Why is this crucial? There are also guidelines that allow drawing to be performed precise and control. So finally, there are special tools used for the installation of the system, which allows efficient operation under such complex conditions. So let's move to one of the most critical processes in this operation, that are the cementing wells in deep waters. Cementing wells in deep waters, well, the cementing involves sealing the space between the casing and the wheel walls with cement. For example, variations in cementing are the temperature. The temperature variation can affect the sealing time of the cement, and the presence of shallow water flows can use water and sand to enter the well during cementing. Cementing wells is an essential step to ensure the stability and safety of the well during and after drilling. To counteract this, the special cements are used in some cases. Nitrogen is injected into the cement to reduce its density without compromising its strength. Well, these advanced techniques allow the cements to harden properly, even under the harsh conditions of the ocean deeps. This operation is a delicate process since any failure in cementing can lead to serious problems like loss of well control or even a blowout. So this operation is very important in the drilling. So now let's see how these wells are controlled using a subsea control system. A subsea control system in offshore drilling, control systems are fundamental to ensure that operations are carried out safely and efficiently. These systems allow surface equipment to manage everything happening on the water. There are five main types of control system. The number one is the direct hydraulic system. This is the simplest and most reliable, where hydraulic fluid travels directly from the surface to subsea complex to activate a control mechanism. The second one is the parallel valve hydraulic system. This system is suitable for greater distance, allowing control of function at a distance using more complex hydraulic signals. The third one is sequential hydraulic system. This one reduces the size of the umbilical but has limitations in the number of functions it can handle. In fourth place, we have the electro-hydraulic system. This combines electrical signals with hydraulic control, allowing for faster and more precision response, especially in the waters. And the last one is the multiplex electro-hydraulic system. This one is the most advanced, which allows controlling a large number of components quickly and efficiently at the same time, offering almost total control of the wall. Well, each system has its advantage and disadvantage. But the most advantage, like the multiplex electro-hydraulic systems, are the most commonly used in deep waters due to their greater reliability and control. So now let's see how risers are designed and select for this operation. Riser design and selection. The risers are conduits that allow the circulation of fluids between the platform and the subsea well. The riser is a key piece of offshore drilling operation. It acts as an ascending pipe that connects the drilling platform to the subsea well and allows fluid circulation. The design of the rise must take into account several factors, such as length, internal pressure, buoyancy, and the ability to withstand sea movements. And additionally, the impacts of waves and currents on the rise must be considered, as they can generate significant stress. A motion compensation system is often used to minimize these effects and protect the riser integrity. The design progress is iterative. Structural and environmental analysis are conducted to adjust each component until the riser is optimized for the wheel's specific conditions. So now let's move to how completion and repairs are carried out on subsea wheels. The well completion and repair in deep waters. The well completion in deep waters wells involves installing equipment that enables the safe and controlled production of hydrocarbons. So the key components of completion system include the subsea tree, which is the equipment that controls the flow of oil or gas from the wheel, and the tieback system, which connects the wheel to the platform. The repairs operation are carried out using workover risers, which allow access to the well for any necessary maintenance without compromising its integrity. Once a well has been successfully drilled in the waters, the next step is its completion, a process that prepares the well for the safe and efficient production of hydrocarbons. This is a crucial step in the process, as a failure to complete it properly could compromise the well's integrity and lead to long-term problems. Additionally, it's important to note that, like any infrastructures, wells requires maintenance and, in some cases, repairs to continue operating optimally. So, with this important note, let's take a detailed look at how competitions are performed and techniques used for repairs in these challenging environments. Well, the deep water well completions. The completion process involves installing the necessary equipment to allow hydrocarbons to flow from the reservoir to the surface. Subsea tree technology plays an essential role here. Subsea trees are devices. These devices are installed on the subsea wellhead that control the flow of oil or gas. They act as a safety valve, allowing or stopping the flow as needed. And there are several types of subsea drills. We have the wet trees, which are used in subsea wells and are designed to withstand the harsh condition of the seabed. And we have the dry trees. These dry trees are used on fixing drilling platforms. The subsea trees include critical components like gate valves, chokes, and subsea actuators, which are remotely controlled from the platform or a surface control unit. So now we have types of well completion. There are several types of completion used depending on the deep and the type of the reservoir. The most common in deep waters are tieback completions. This type of completions use a rigid connection from the well to the platform or floating unit at the surface, allowing more direct access for well control. We have the mudline suspension system. This system are primarily used in shallow and medium deeps. They allow the production casing to be suspended near the sablet with a tieback system that connects the equipment to the platform. An advanced system for completion is the use of suspension system and tubing hangers, which provides a precise and secure connection between the production tubing and the subsea tree, ensuring this well integrity. We have the deep water well repairs. Over time, subsea wells may require maintenance or repair due to natural wear, corrosion, or mechanical damage. These repairs, workover right system are used, allowing the direct access to the wheel from the surface. The workover risers, these are conducts that allow access to the wheel from the surface to the perform maintain task, such as replacing valves or damaged components in the subsea tree. These risers are equipped with special tools to handle and replace defective equipment. When components like the subsea tree or tubing hangers need to be repaired, installation and recovery tools designed specifically for this operation are used. These tools allow damaged components to be removed and replaced without compromising the wheel safety. Well, the tools and repair process. The repair process for a subsea wheel involves several stages. First one, we have the disconnection of the subsea tree in case of several damage. Second one, we have the inspection and diagnostics. Once the equipment has been retrieved, a detailed inspection is performed to identify the problem. And finally, we have the installation of new parts. New components are installing using testing and handling tools to ensure the equipment is properly sealed and functionally correctly. All of these three All of these three stage is done using advanced technology, such as remotely operated vehicles, or ROVs, and remote control systems. These ones minimizing the risk for the operation. So this process can take days or even weeks. That time depending on the complex of the damage, but it is essential to ensure the well's long term safety and offensively. As we have seen, both the competition and repairs in deep waters are highly specialized, that require advanced tools and careful planning. However, with modern technology, it's possible to carry out these operations safely and effectively, ensuring that wells continue to produce oil and gas steadily and without interruption. So now let's summarize the key takeaway from this video. Well, my conclusion is, in summary, the water drilling is a highly special process that requires advanced platforms, innovative equipment, and a reliable control system. The technology continue to evolve to meet the challenge of drilling in increasing hostile and deeper environments. Over time, we are likely to see even more advanced developments in this area, allowing the oil industry to continue exploring and producing the most remote parts of the world. So this is all the information that I have for you. Thank you for joining us in this exploration of deep water drilling technologies. I hope you find this information on self and interesting. So thank you for watching my video. I hope you can understand my speak. So thank you for watching. Bye.